Hello everyone, welcome back to Calculus BC. We're in lesson number 36 where we're talking about logistic growth. We're going to do three multiple choice questions in this video, but before I do that I want to show you guys that there's another way to represent logistic growth as far as a differential equation. So the one that we've done in the first video, the one that I showed you guys, was dp over dt is equal to some value k times the population, and then we multiply that by 1 minus p over L, where L is the carrying capacity. So this is the one that we've been using and what I discussed in the very first video. What I want you guys to notice about this is that this says C, and C is the carrying capacity. So we can just say, and it doesn't matter what letter you necessarily use for this. So C, L, they're the same thing. What I'm going to do is I'm going to rewrite this, the one that we actually already used, because this right here is derived from this. They're the same formula. So what I'm going to do is this. I'm going to show you guys how to get the other one, and then kind of the point of the two. So I'm going to go ahead and leave the KP alone, and I'm going to create one fraction, right? One fraction, so I'm going to multiply 1 times L, which is L, minus P all over L. So if I were to simplify this, if I were to break this equation, this fraction back apart, I would be given 1 minus P of L. So I haven't changed anything there. That was just simple algebra. Then I'm going to pull out of my parentheses here 1 over L. So I'm going to get Kp over L, and then I'm going to be left with L minus P. L minus P. And guys, again, just like before, this K over L is still a number. It's still a number. So I'm going to go ahead and just create a new K that's going to represent K over L. So a new K, K's 2, if you will. P, and then I get L minus P. And then I just told you guys that L and C are equal to each other, so I can rewrite this. Instead of actually having an L, I can have a C, and we're back to right here. So what is the difference between these two? Which there really isn't anything. What I want you guys to take out of this is that if you see a 1 here, a 1 minus a fraction, this is always going to be your carrying capacity. Right? This is going to be your carrying capacity. However, if you do not see a 1 minus, and you see a number minus 1p, then this is going to be your carrying capacity. That's going to be your CC. So let's take all of that. And is one better than the other? Absolutely not. It's just how it's actually given to you guys in part of multiple choice questions. So let's actually look at the three examples I want to show you guys to finish this lesson. So example number 5 says a population of students having contracted the flu in the school year is modeled by the function p that satisfies the logistic differential equation. And it usually gives you guys something like this. So P over 600 multiplied by 2 minus P over 800. It says if P of 0 equals 100, so P of 0 equals 100, so we're right here at 100, we want to find the limit as our function approaches infinity of P of t. So remember, all differential equations, or all logistic growth graphs look something like this S-curve thing. And so we're going to plateau out right here. And so we're going to understand that this limit as t approaches infinity is always going to be equal to our carrying capacity. That's what a carrying capacity is. What is the maximum value that something can reach? So it's never going to get to our carrying capacity, but what is it? So this is L. And so based on what I showed you guys earlier in this video is you got to figure out what the carrying capacity is here. Well, since I see that this is not 1, I need to manipulate our differential equation. So dp over dt is equal to, I'm going to leave the p over 600 alone because that doesn't really matter. I'm going to get one fraction here, so I'm going to go ahead and do 2 times 800, which is going to be 1600, minus p all over 800. Now, just like what I just talked about at the beginning of this video, I'm going to pull out the 1 over 800, and so I'm going to get 4800 out here, and I'm going to be left with 1600 minus p. And so this is the form I just showed you guys. This is the form I just showed you. So this right here is our carrying capacity. It's our carrying capacity. So our answer to this problem is going to be, what is this limit? The limit's going to be the carrying capacity. Our carrying capacity is going to be 1600. Yes, ladies and gentlemen, you can always multiply these two numbers together, assuming that this is just 1p to get what your carrying capacity is. So this is the form that I just showed you. But again, we have to rewrite this. So this one was kind of a hybrid of the two that you're going to see. So you just want to know what the carrying capacity is for these problems. So let's look at another example. So question 6 is actually going to take us back to what I discussed in the very first video of this lesson. It says a population is modeled by the function g that satisfies the logistic differential equation given to you right here. If g of 0 is equal to 1, then what value of g is the population growing the fastest? So population growing the fastest. So what I talked about in the video in lesson number 1 is that the population is always going to be growing the fastest when it's our carrying capacity divided by 2. That's all it is. It's always going to be our carrying capacity divided by 2. So if you guys can look at our formula right here, you guys can see that this is written again as the very first one we did. So Kp times 1 minus RL, or P over RL. So guys, this is what's awesome about this problem is the fact that this is a 1, and that's exactly what we're expected to be here. So RL, our carrying capacity, is actually just simply 4E. And so going the fastest, we're going to take our 4E, we're going to divide it by 2, we're going to get 2E, and so our answer here is going to be C. So a lot of these logistic differential equations that you may see on the BC exam is just assuming that you guys know how to read the equations and then answer these questions. So whenever I'm growing the fastest, it's just the carrying capacity divided by 2. If it asks you guys, what's the limit as the graph approaches infinity, that's always just going to be what your carrying capacity is. And the other question it's going to ask you is, let's look at the graph of it, because we haven't used any of the initial values, right? So they give us the initial values in both examples 5 and 6, but we didn't need those because they didn't ask us anything about it. Well, in this example 7, we're going to actually have to use the initial value as well. So it says, given the differential equation given by here, and it's not actually given us, anything particularly. And again, guys, the y can be represented as p's. It's the same thing. X can be represented as t. It's the same function that we did at the very beginning of this video. Let a y equal f of x be the particular solution to the differential equation where f of 0 equals 2. If x is greater than 0, what is the range of f of x? What's the range of f of x? So this actually takes into account something I did in example number 5. We know that the most this function is going to be is our carrying capacity, and it's given to us right here as L. We're never going to reach it. We're never going to reach the carrying capacity, but we know we're at least going to get close to it. And so we know that our graph function looks something like this. And we know that we're starting, right? We're starting when x equals 0, then we know that this value is going to be 2. So it's going to ask us for the range of this. So we want to know what the range of our value of our graph is. So we want to know what all of our y values are going to be of f of x, because this is the graph of f of x. If we were to solve this differential equation, we would get y equals f of x. Well, we know that we start at 2. And we're going to include 2. Because when x equals 0, then we have the value of 2. So you always do include your initial value. And then we know we're going to reach L, but again, this is an asymptote, and we're never going to reach the carrying capacity, so we're not going to include it. So this answer is going to be D. So most of these logistic growth problems that are on the BC exam, and all 3 of these were questions from the BC exam, previous BC exam, that it's just kind of knowing how to manipulate your equation, looking at what your equation is, and understanding what you need to do. So that's it for this lesson. I hope that you guys, this makes sense to you guys. I will see you guys in the next lesson. Take care.